Hi students, we will begin our quadrilateral unit with parallelograms. So first of all, in this unit about quadrilaterals, it's important to know that quadrilaterals are four-sided shapes. Quad means four, lateral means sides, so quadrilateral, four sides. And we've learned about quadrilaterals when we learned about the interior and exterior angles of polygons. Okay. So the first of the many shapes that are considered quadrilaterals is parallelograms. Okay, so many of you have an idea of what these look like. This is kind of what a parallelogram looks like. So in your notes, I want you to go ahead and draw one, and then as we learn about its properties, we're going to mark it up. Okay? The first property of parallelograms is that opposite sides are parallel. So this is going to help us to conclude some other things about the parallelograms' angles when we go back and think about parallel lines and transversals. But let's go ahead and first mark it on our picture. Opposite sides are sides that do not intersect in a quadrilateral. So this side and this side would be parallel, so I would show that with my arrows. And then we have another pair of opposite sides. So that's the first property. So the first one was opposite sides are parallel, and that's actually the reason why parallelograms have their name, parallelograms. But the second property is that opposite sides are also congruent. So these two sides have the same length, and these two sides have the same length as well. Whoops, what am I doing? Let's do one tick through those. Okay, so there we go. Opposite sides are parallel and congruent. The third property is that opposite angles are congruent. So you will have a pair of opposite angles that are obtuse and a pair of opposite angles that are acute. Okay, which leads us to our fourth property. Consecutive angles are supplementary. So for example, these two angles, those two are going to add up to 180, and here's why. If these two lines are parallel, and this is my transversal, then these two angles in my parallelogram, those are same side interior, they're supplementary. Okay, so that is going to hold true all around the parallelogram. So these two angles add up to 180. And then the next two pairs of angles add up to 180 and so forth around. Remember, consecutive means next to, whereas opposite means across from. So these two also add to 180. Okay, now the fifth property. Diagonals bisect each other. So diagonals in quadrilaterals connect opposite vertices. So here would be one diagonal, and here would be another. And sorry, mine are so wiggly. They look horrible. All right, it's pretty good. Okay, so those are the diagonals. Now what they do is they bisect each other. So that first diagonal I drew bisects the second one. So that means these two halves are congruent, and then vice versa. So which means these two halves are also congruent. Now notice, I don't know if you can tell, but those diagonals are not equal in size. Okay, so I need you to know that they're different lengths. One will always be shorter and one will always be longer. The shorter one is the one that connects the obtuse opposite angles. The longer one is the one that connects the two acute opposite angles. All right, so these are our properties. Make sure you have this picture drawn in your notes somewhere, and make sure you have these 5 properties written down, because what we're going to do in our next lessons is talk about the other sorts of quadrilaterals, and they have different properties. So we're going to have to somehow get these properties straight in our head. All right, let's do some examples. Okay, so the first thing we're going to do with this parallelogram is we're going to name it. So we're going to give it a name based on its vertices. There will be 4 vertices in any quadrilateral. So to name it, you can put a little tiny quadrilateral symbol. Sometimes you'll see that, sometimes you won't. I'm sorry, a parallelogram symbol. And then you'll pick the 4 vertices And you can start with any of them. So if I started with D, for example, I would list the other vertices either going clockwise around the shape, so DABC, or going counterclockwise around the shape DCBA. Okay, so I could pick one of those. It wouldn't matter from whatever vertex you started with. Okay, but what you couldn't do, what you couldn't do is you couldn't, so the vertices have to go in order, consecutive order, but what you couldn't do is jump across the shape. So I couldn't call a shape, a parallelogram, DBCA, right? I couldn't jump over to the B and then to the C and then to the A. I've got to go around the shape somehow, if that makes sense. So we can practice naming those if that messes you up. Oops, I'm just going to rewrite it. Okay, DABC. Okay, so that's one example. I could also call it parallelogram BCDA, BADC, ADCB. Those are all good. All right, next one. Segment AB is parallel, don't forget that notation, to what? That's going to be the side across from it, which is DC. So remember, these two sides are parallel. And don't forget, we have another pair of parallel sides. But AB is parallel to segment either DC or CD. Either way is fine. Oh, I wrote that on the wrong line. Oops. DC. There we go. Next one. Segment DA is congruent, of course, to the side across from it, the segment across from it, which is BC or CB. And remember, AB is also going to be congruent to the side across from it, which is DC or CD. All right, now we're looking at angles. Angle CDA is this angle here. That's going to be congruent to the angle across from it, which I could either call angle CBA or angle ABC. Either of those is fine. And then the last thing, I've got segment DE, which is this guy right here, and it's going to be congruent to the other half of its diagonal, which is over here. I could call it segment EB or segment BE. Either one is fine. So those are what some of the congruent parts are, or parallel parts are. Now we're going to use those in problem situations and try to set up some equations to help us find some unknown values. Okay, so in this example, it says if ABCD is a parallelogram, then the measure of angle A equals x degrees, and the measure of angle D equals 2x minus 3 degrees. Find the value of x. So the very first thing we need to do, since we don't have one, is sketch a parallelogram, okay? If you make it a little longer, instead of kind of more like this actually looks more like a rhombus and will confuse you when we get to rhombus. So try to make your parallelograms kind of long. That'll help you remember some of its properties better. All right, we're going to go ahead and label it with its vertices. Now I could start labeling it at any vertex, and then I want to continue with the order of those vertices, either clockwise or counterclockwise. I'm just going to start down here and go clockwise, A, B, C, D. It doesn't matter. It says the measure of angle A is x degrees, and the measure of angle D is 2x minus 3 degrees. Whoops. Okay. Find the value of x. So I have to think, how are those two angles related? Okay, one of our properties said that consecutive angles are supplementary. Remember, if these two lines are parallel, as they are in a parallelogram, and this is my transversal, those two angles are same side interior, so they add up to 180. Okay, so let's go ahead and set up our equation. X plus 2x minus 3, the other angle, equals 180. And now we just have to solve. So combine like terms. We've got 3x minus 3 equals 180. Move all your constants to the other side. So we'll add 3 to both sides. So 3x equals 177. And then we'll divide both sides by 3. Okay, it looks like I made a mistake. Let me back it up. 180 plus 3 is 183. Come on, Miss D. Now when I divide by 3, x equals 61. So we found our x. So if we wanted to go a step further and find the measure of those two angles, we can plug in that value for x. All right, let's try another one. We'll probably have to draw a picture again. XYZW is a parallelogram with diagonals XC and YW that intersect at point A. So let's start there and first draw and see if we can make it look right. So XYZW, it says the diagonals are XZ, yes, and YW, okay, that intersect at point A. There we go. All right, let's go ahead and label now. So it says if XA is 3m and ZA is 5m minus 4 and YW is 10m, find m. So this is 10m. Okay, so we've got a lot of information here. The things that are congruent, I know that XA and AZ or ZA should be congruent because YW bisected it. I know that the two diagonals are not congruent in a parallelogram, so I don't think I'm going to do anything with the 10m. I think that's extra information. So let's go ahead and set the 3m equal to the 5m minus 4. So make sure you're not tricked. I'm going to first get all my m's on one side, so I'm going to subtract 5m from both sides. So I've got negative 2m on the left equals negative 4 on the right. Now I'll divide both sides by negative 2, and m will equal positive 2. Now I could go a step further, of course, and plug it into all of those segments to see how long all of those diagonals are. Okay, on these examples, these are a little simpler. We don't have expressions that are more than just a variable. So we'll be able to kind of work backwards from what we know to figure out some of these values. All right, so let's go ahead and let's start with, on number 4, let's start with the 80. So I know that angles that are opposite each other equal each other. So I know that x also equals 80 degrees. Okay, so there's one. All right, and then z, I know that z and the 80 should add up to 180 because those are consecutive. So those should add up to 180. So z is going to have to be 100. Right? Nope. And then if that's 100, then this angle down here is 100 because those are opposite each other. And then y is right next to that, and I know those two are a linear pair, so those are going to add up to an 80. So y has to also be 80. All right, I can also look at this another way. I could look at my parallel lines, right, because I know these are parallelograms. And then that's my transversal. So this 80 and the y has to also be 80 because those are corresponding angles. So don't forget the properties we've learned in the past still hold true for new stuff because those are inherent in every time you see those situations like parallel lines and transversals. All right, let's look at number 5. So that 120 is across from z, so I know that z is 120 degrees because those are opposite and congruent. Let's see what else. So I know that this 120 with this 35 plus x, those need to add up to 180, right? So what I can do is I can make a little mini equation. I could say 35 plus x plus the 120 all equals 180. Okay, so if we combine like terms, the 35 plus the 120 makes 155. And then if I subtract 155 from both sides, x is going to equal 25. So that means that little angle right here, this little x right here is 25 degrees. Okay, so there's that one. And then we also know that opposite angles are congruent. So that 35 plus x, which is 25, that adds up to 60. That's great. That means these two over here add up to 60, but I want to know what y is. Now here's something that's true about parallelograms. The diagonals do not bisect the angles. Notice the 35 right here. See where the 35 is, and then right next to it, that x is 25. But what is true, all right, check this out. Parallel lines, transversal. I can look at my diagonals as transversal. That 35 and that y, those are alternate interior angles, so those should equal each other. The y is also going to be 35. So it's kind of like they're opposite, right? Like these two are congruent, and then I could change my color, and then these two are going to also be congruent. So they're kind of like on opposite sides of that transversal. So y is 35 degrees. All right, let's look at the last example on this page, 6. So first of all, the one that looks easiest to me are the z and the 70. Those are going to add up to 180 because that's a linear pair. So z is going to have to be 110. And then I see that 30 and that x, and I know those are congruent because those are alternate interior angles, just like the yellow ones on the one next to it. So I know that x also equals 30 degrees. Now we have to figure out y. Okay, let's see. So first of all, if x is 30, right, and I know since z was 110, that means this angle is also 110 because it's vertical with z. And I know that the 110 and the 30 are going to add with the y to equal 180 in that top triangle because all the angles add up to 180. So 110 and 30 is 140. So y has to be 40 degrees so that it adds with them to equal 180. So y is 40 degrees. I hope those make sense. Let me know if you need help with understanding any of those. All right, we got one more example. All right, we've got a picture here. Let's see what we know. We've got a lot of things already labeled. It says measure of angle ZWX equals B degrees. ZWX, that's these two together, that's B degrees. And the measure of angle WXY, that's these two together, equal D degrees. Okay. If you look at those real quick, since those are consecutive, I know those are going to add up to 180. So maybe I want to make myself a note so that later on I will remember that. Okay. Find the values of A, B, C, and D. Okay, so let's see what we already know. I know that that angle B is going to equal these two angles added up, right, because they're opposite. So that's 18 plus 31, which is, what is that, 49 degrees. So that means B equals 49 degrees also. So there's one. Now if B equals 49 degrees, remember B plus D, that equals 180. So that means D is going to be 131 degrees. Okay, so we got those. All right, A is going to be congruent to the 15 because those are two halves of our diagonals, and our diagonals are both bisected when they intersect each other. So A has a length of 15. And then let's look at where the C is. This 2C is going to be equal to 22 because those are opposite sides and opposite sides are congruent. So 2 times what is 22? 2 times 11 is 22. So C is 11. All right, bring me your questions. I'll see you in class.